This video covers modules 22 and 23, where we will look at human population dynamics. So there's our focus. We'll look at age structure diagrams, total fertility rate, human population dynamics, and demographic transition. Scientists do disagree on the Earth's carrying capacity for humans. Our current human population is over 7.5 billion people, and humans have been experiencing a period of exponential growth for the last 400 years, which gives us the question, are humans constrained by limiting factors like we know other organisms are, where, after this long period of exponential growth, they will experience overshoot and die off? I don't know that any of us will live long enough to know the answer to that question, but hopefully everything is okay. There are many factors that affect human population growth. They are like whatever the current population size is, birth rates, death rates, fertility, life expectancy, and migration. When we talk about demography, we're talking about the study of human populations and its trends. So let's start with the population size. The population size of a country, for example, is influenced by birth rates, death rates, immigration, and immigration. Populations increase when birth rates are higher than death rates, and or immigration, so people moving in, is higher than immigration, people leaving to go live somewhere else. Some important terms and calculations will be crude birth rate, which tells you the number of births per 1,000 individuals. Crude death rate is the number of deaths per 1,000 individuals. Global population growth rate is calculated by the difference between crude birth rate and crude death rate divided by 10. So if a population is increasing, that value is positive. If it's decreasing, it's negative. National population rates are calculated by adding crude birth rate and immigration numbers and then subtracting that from death and immigration and dividing it by 10. And the doubling time tells you how long it takes for a population size to double. We can calculate that using the rule of 70, where you take 70 and divide it by the growth rate. This graph shows you what our population increases has been since 1900, and then the estimates of ranges of where we might be within the next 100 or so years. So we will either start to level off, keep increasing, or perhaps start to decrease. When we talk about fertility, we most often talk about the total fertility rate, or TFR, which is the average number of children a woman has during her childbearing years. The current US TFR is about 1.7. Replacement level fertility is around 2. So 2 people have, 1 child to replace each of them for when they die. We notice that the TFR is generally lower in developed countries than it is in developing countries, and we'll talk about some reasons for that in a minute. Life expectancy is the average number of years a person can expect to live, and that will be based on where they live. One thing that we know is that females generally live longer than males do. Life expectancy is generally higher in developed countries. Our global average is about 70, where the US is about 76, but we are for sure do not have the highest life expectancy on the globe. When we talk about life expectancy, we have to consider infant mortality, which is the number of deaths in children under 1 per 1,000 live births, and child mortality, which are deaths in children under 5 per 1,000 live births. So in areas that have higher infant mortality and child mortality, their life expectancy will not be as long. And we see that in a lot of places, particularly in Africa. Net migration is the difference between immigration and immigration. And we know that populations will increase in an area where they have a higher immigration with an I than immigration with an E. Next, we'll look at age structure diagrams, which tells us the distribution for males and females individually of how many individuals are within that age range. And this can help us see where population growths and declines are. So if we look at age structure diagram A, this is a picture of India, or an age structure diagram of India, and we know that their population is increasing quite rapidly, which we can see based on the age structure diagram, because they have way more individuals under the age of 20 than they do older individuals. B is a picture of the United States. It's relatively stable at the bottom and then decreases as you get older. And you can see Germany is a little bit different. They for sure have more older people, so that would be indicative of a declining population. And then China, same sort of thing. Their population might be starting to slow a little because they don't have as many younger individuals that will be reaching reproductive times, soon. That leads into the theory of demographic transition, which says that as a country moves towards industrialization and increased affluence, it undergoes predictable population changes. We will talk about 4 stages, but sometimes you'll hear that there are 5, and that's okay. There's a little bit of a struggle of, is there really a 5th stage of demographic transition? But for the purposes of this class, there are 4. And we'll look at what is occurring in some example countries for each of these phases. In phase 1, we have slow population growth because there are high birth and high death rates. So when you have the same number of births and deaths, your population is staying relatively the same. There are few, if any, countries in this phase. For a while, there were no countries in phase 1, but some have been pushed back there because of certain epidemics like HIV and AIDS. The US and Western Europe was in this phase before the Industrial Revolution, so we've been past phase 1 for a long time. During phase 2 of demographic transition, there's rapid population growth. The birth rates are still high, but the death rates start to decrease. And that could be because of improved medicines, better sanitation, and things like that. India is currently in phase 2 of demographic transition. In phase 3, we have stable population growth. We have a better economy, better education systems. Birth rates start to fall. We have more affluence. The US and Canada would be examples of countries in phase 3. In phase 4, we start to see a declining population growth. We have even higher affluence. These would be places like Japan, the UK, Germany, Russia, and Italy. We have fewer young people and more old people, and that's why our population is declining. The graph on the right shows you the total fertility rate based on per capita income, which has been converted into US dollars. This is from a few years ago, so the US is actually a little bit lower now. But what you notice is that TFR is way higher in areas with a lower per capita income. And there are a lot of reasons for that. In some of these places, it might be an advantage to have lots and lots of children to help take care of the farm or property or things like that. The other reason is because in some of these places that are developing countries, they have a higher rate of infant and child mortality. So a woman will have more offspring in the hopes that a number of them are able to live to adulthood. And some of it is lack of access to resources, like birth control can keep births higher than it is in developing countries where it's quite easy to, do some family planning or use birth control, and have the knowledge to be able to do that. So that has impacted TFR in a variety of developed countries. So that kind of ties into what we're talking about next, which is family planning, which is regulating births. There are lots and lots of methods for that. They are more common in developed countries, and that's simply an access issue. So in places like the United States, it is very easy to get any form of birth control you could possibly want. But in some developing countries, particularly in Africa, there is simply not access to those things. And so without birth control, you're going to have more births. Another thing that we've noticed is that women in developed countries are having fewer children. Some of that is because their age at the first time they give birth is a little bit higher. which means that that woman will have fewer children throughout her lifetime. So that's going to decrease the TFR. Some of that is because in these places, women are working and being educated, and with that comes, the knowledge of how to use birth control, and with that, having a good job and not wanting to stop and have children until they're a little bit older. So lots of reasons there. I'm sure you could maybe even think of one or two more on your own. Population sizes and economic development contribute to consumption of resources and to the human impact on the environment. And there are shocking differences in resource use in developed versus developing countries. So let's look at these two graphs here. The one on the top has the human population size in millions in several different countries. The purple ones are developed countries, and the bluish ones are developing countries. So you can see at the time this graph was made, the US had about 315 million people. And then China and India are just way, way, way above the rest when it comes to sheer population size. So what we want to do is look at that and compare that to the graph below it, which is the ecological footprint per capita. So the global average is about 2.7, and the United States is 9. So we have, maybe a quarter of the world's population, but our ecological footprint is substantially higher than most other countries and the global average, which from looking at other examples here, you can kind of see that is that the developed countries have less of the world's population, but their footprint is way higher. So we'll look at some reasons why that might be the case. We can calculate it's hard to get these actual numbers. It's a little subjective, but the human impact is equal to the population times affluence times technology, and that can estimate the human lifestyle impacts on the environment. We know affluence for sure makes an impact. So our GDP, our gross domestic product, measures the products and services produced in 1 year in a country, which one of the things we notice is that that does correlate with pollution levels. Countries with a higher GDP do have more pollution. They're, burning fossil fuels and things like that. So there will be more of a human impact in those areas. Impacts on the environment can, of course, occur locally and globally. Local impacts will be typical of rural agriculturally based societies. Things like overuse of the soil with nutrient depletion will impact locally. Global impacts are more common in affluent and urban societies. What we know is that half of the world's population lives in an urban area and consumes 3/4 of the world's resources. So it actually does make a global impact, even though that's not or it's only half of where the world population is. Which leads us to the question is, can we have economic growth and environmental protection? I know that it's not an easy question to answer. I hope so, but I think it is a lot of things will have to change, both with legislation and putting restrictions on things, and the hard part is changing societal views on things and having more people care about what happens to their area. So that is all for your module 22 and 23 notes.